welcome back. So I was watching this, and I really, so it's Laramide, orogeny, the the Rockies in this region, here and down here, and he circled basically this. So maybe I can find it. I think he did. It might have been a different one. I could have sworn he did. Okay, besides the point. Generally in that region, possibly inclusive of this, as being considered part of the Laramide orogeny. Initiation of the orogeny is 75 to 65 million. And then he said that the Montana one, he said 65 million, but it says 55, so I think he just misspoke. Because if it was 65, that would be interesting, but because I was just looking for a bunch of things that happen at 65, maybe there's other reason that he said 65 that is correlated to it that made him say 65. That's not from this specific chart that this one's kind of not including, but I think it's just 55. Okay, but essentially though, the whole, so this is what I found interesting about this is the whole of the Laramide orogeny began simultaneously, but then it ended sooner in the north and later in the south. So like, let's just say that there's a current involved in this, and it's actually coming this way and through here, and like propagates as this like hand of God structure that I've been talking about as the thumb like nail down this way. I don't know why it would propagate like that. If that's like a thing that it does. But in essence, a current here, this current flowing here that then reaches down here and busts through into this region. So this here we've talked about in the past is generally over here. Is here, so like this is Bighorn Forest is right here, centered on it. This, so the fingernail of the Laramide orogeny, northmost section, pretty much, relatively. This section is right there. And then the orogeny, maybe it's down this, like this region. I don't know. Let's see what this corner is. 10 minus 105, 36. I'm over top of it. I really like to not hide it. We can even look at the total intensity thing. Okay. So 105, 36 pretty much. So 36, because it's backwards on this. Minus 105. Cool. So right there is this. So this region of the Laramide orogeny is closely tied to whatever's going on here. Mind you, this is going on also here, not in the same location. This is tied to the Galapagos hotspot, I believe. This location, as the continents are severing out in the open, this structure's forming, which has similar features of like a magnetic field looking structure, and then like a body. I look over, I'm also streaming, so I guess it's actually reasonable right now. But the magnetic field structure here, here's Yellowstone over here. So like Bighorn Basin, dense, cold structure past some like central point here that maybe is relevant to like this, like the material down the center here, the basins, the more so sandy stuff between here and here. So like here in this region maybe as like a almost like the boundary between this system and this system, like the dense positive, subtle negative, basically the current and the masses that were equal opposite to one another, interacting and producing specifically interactions down into this region because there wasn't a pressure up here, because there was a wall blocking pressure from flowing this way, so it flowed around the wall more so. The current that was flowing across here and out here flowed this way and up here and maybe into here a bit, but like I think especially out here and then up. So it wasn't really flowing, I guess, into here. I thought it was. Maybe it is to a degree. It may be that what's flowing in here actually is more from because this current under Australia going up this way may have been flowing this way for a time, and then maybe it moved over this way and flowed in this way for a time. I don't know why I would do that. Like exactly as the system changed, it's the ammonite structure in Australia. As this system changed, maybe it changed the direction of the current that was propagating underneath Australia, generally speaking, to be more over that way. And then once it did that, maybe it like severed the crust here and it just floated away in the currents as the earth expanded. I don't know why that, like maybe by the pressure into this like solid system wherever here is able to flow maybe up into this region. I don't know. Just thoughts on like it seems like there's two currents colliding. And I was thinking it was this coming back and colliding with this, but that's a sharp turn. Like in order for it to, I basically was envisioning just some kind of pressure here from like this current and other currents like bending in the region, I guess. But I wasn't envisioning just like a head-on current of the Australia current, so that might actually be what's going on. Australia current. That's a problem, is I keep changing my interpretation, but I do think I'm like that the currents are occurring and do provide explanation for geological formations is present. Like we just went from the Bighorn thing down to this region, and I assure you this has never been connected to the Rockies in some substantial way to this, to Bighorn Basin or forest and the overall structure being tied closely to the actual formation process of the Rockies. So to even notice the structures in the positions means it's relevant enough that even if the currents aren't exactly worked out, that it's at least like in the direction of shedding light on things. This looks almost like, I'm pretty sure, like there's a structure here that almost holds a boundary in the land. I'm not sure. I mean, the explosion would be here in like a glancing blow. Maybe there's something of that nature going on there, where it puts like current that way, and then it starts to deflect down and like sawtooth the whole coastline. Oh yeah, it even has like a sharp sawtooth thing going on, like a bend, like a shallogram. Which are not fossils. Like physically carving and at the same time creating like a mountainous terrain. This one is incredible. Let's see, maybe we can look at these a little bit and actually. This one is just so detailed that it might shed some light. I almost need to get into the zone of thought about these things, though. Like what's going on and be like flowing with the currents and consciously aware of the currents. I'm like, it's hard to like just glance at it and be like, and like be back in a state of mind, because I know I've looked at this and be like, whoa, and gone through it in a way that I feel like people who see that would be like, that's pretty crazy. Those parallels being present, whether or not it's valid. But like it opens up also particle exploding is, this one is by far the most like shallogram though. No particle because it's over here exploding and being frozen in time. Pretty much this is what was going on, is the currents were colliding, like a current this way and a current this way were colliding, but like pinched at an angle that was pinched, like off balance, and it just exploded. the the particle that was forming at the pinch point between the currents, and that explosion propagated physically this way here, but the explosion was from here, causing force up this way, which was like this. So we can kind of see it over here. So it was going up the coastline, but also it has You'll just have to pause, rewind, or whatever if any of this is too fast. Sorry. Just look at it or go to the website, check it out. But there, it goes inward too, I noticed. And I'm pretty sure this is related to this separation occurring. But I wonder if there's like propagations in this way that are related to this. Like, I'm pretty sure this is related to the Caribbeans being formed. This is basically the boundary here. Okay, sorry. I'm just kind of staring at it. Okay, so termination though, so like this strongly suggests that there's a current coming in, so from down here, up here, I mean. So there's three currents here. There's one coming in from under Europe, and then under North America, and then specifically east of North America, that goes down the coastline here. Pretty much this whole region, that then when it reaches around Florida, this region, it begins to fan out. And then it runs into resistance under North America. So, like, those currents are not this current. So there's this current going this way, and then the second current opposing it over here, coming in this way, which is actually coming from up here, from the North Pole region that was shaped to be a pole, at least, like a shallogram, with spirals around it and all. I know, fast. I'm just going, but then the current comes down this way and comes across here with this width here, and just fans out into exactly opposite this current. Wow, this current's coming down here, and so this current begins to like feed through them in a way where like the end of the process has this type of thing going on. The termination is later in the south because the current is flowing through the region. Okay, but the reason I wanted to play this, and I don't want to get too distracted, is he starts talking about the Rockies, talking about the Rockies, talking about the Rockies. You know, it's a video about the Rockies, right? It's a video about the Rockies. Okay, that's clear. There's a video about the Rockies.
I can't say exactly. Less precise. It's probably not accurate anyway, but it's not. The precision gets worse. So it's a couple of things to see here. Basically, of course, the wave is because that's the plate motion. That's what it's caused by. That's why these features move. They always move because they're due to plate interactions.
Don't worry if it doesn't make complete sense. I'm more so just letting it play.
You'll notice that as this blue area moves back, a particularly dark area forms. A sort of a bullseye zone that heads out here. It gets out here around 90 million years ago. Just playing it backwards. An area of particular deep, at least modeled, history or substance.
I'm not sure what to make of this.
And that's a very important feature. In fact, that feature that gets there about 90 million years ago is
It's like a counter current of elevation difference.
this feature here. So it's about 90 million years ago. These are areas of, this is an effective temperature down at a depth of 200 kilometers. Yeah. So the key point is that the prediction is that this feature is something that would have been at the shoreline. Now this is paleospastically restored, sort of the western, southwestern U.S. at around 90 million years ago. And this feature has been interpreted by other people different ways in the past. That feature is referred to as the conjugate Shatsky rise. This comes from plate tectonic, people studying plate motions in the Pacific. In the Western Pacific, there are these large oceanic plateaus, including the Shatsky rise. Shatsky rise is about 600 kilometers by 300 kilometers across, and it's
We're talking about, I believe that's the Pacific Ocean seamounts. Go on, please, sir.
it sits above the seafloor around it between 2.5 3 kilometers higher. People have dated it, and they've gone back and seen where would it have formed based on plate motions. Plateaus, including the Shatsky plate motions in the Pacific. In the Western Pacific, there are these large oceanic plateaus, including the Shatsky rise. Shatsky rise is about 600 kilometers by 300 kilometers across, and it sits above the seafloor around it between 2.5 3 kilometers higher. People have dated it, and they've gone back and seen where would it have formed based on plate motions at the time when it formed, what was the setting. And these suggest that the Shatsky rise formed along the spreading center between the Farallon and Pacific plate, and the interpretation of the volcanism and
Along the spreading zone. Remember what I was just showing, that ridiculous image? Here's Shatsky Rise over here, actually, on this image. This is not quite right. I'm pretty sure this folds up here. So it's probably more relatively over there, even. I'm not sure what to make of the Shatsky Rise thing. I was even thinking, I'll keep playing, but I just wanted to point out, this is a... Wait. What?
the fact that it's sitting on the ridge has been interpreted to be that it was a hot spot sitting beneath the spreading center. Hot spots like that do exist beneath spreading centers, and what they do is they create mirror images of each other because the spreading center is pulling away. So anything that happens on this side more or less would happen on the opposite side. This one would have been called the conjugate Shatsky rise because that's the Shatsky rise.
You mean like this kind of mirror? Relative opening? Possibly opening, but relative to over here, this is kind of the opening compared to this side. Large basin, islands, W-shaped things. Even the shapes of the contours. I know this is missing elements. It's just to show the mirroring. that is present between the two. It just is. There's really no denying they have quite similar features. Mirror, like this is a bay. This is an island. I find that aspect, and it's also like this one is facing this way. This one is facing this way. There's probably other parallels as well that I'm not really aware of or pointing to. Certainly both. Not aware of, but could be pointing to if I like look closer. There's probably something like maybe even like up here mimics Sulawesi. Let's see. I didn't think if it, about like beyond that. It's at this point, this is where the Philippines would be. Sulawesi, I think really would have been in material from somewhere like in here that just bent out by the pressures. Pressure comes in this way of that current underneath Florida, basically. And then this current comes across this current and fans out to this far. Or maybe it actually comes across this line right here and just gets focused to a beam. Like that then flows in a narrow channel that goes initially under South America as a narrow beam here without like a flame type structure, but more so longer. Okay, let's keep going.
You can see that today. We go here into the northern Atlantic. Here's the mid-ocean spreading center in the Atlantic. Here's Iceland. Here's a hotspot track. Iceland's about 17 million years old. So when the hotspot was approaching the ridge at the time, notice that land formed on both sides from eruptions. It's the same idea here, that there would be one side, Iceland, and then the conjugate Iceland on both sides. So the idea is that there would be land produced on both sides. This idea has been around for a while. The downside of it, of course, is that there's no evidence that this thing existed. There's no docked. Eventually, this thing would move across the Pacific on this plate and dock in North America. And you can't find physical evidence of that rock at the surface.
Interesting. But see, that's based on plate tectonics. When the reality is like it was like this. So like this plate slid away, moved away all out of the region, and it didn't really have like a mirror conjugate thing like also move away. It was the mirror conjugate thing of this boundary was the boundary itself, so it just kind of stayed there as the plate moved away. So my thought is that thing is really like this goes up this way, and so like it must be where this current crosses it. Initially, it's hard because it's like I'm fairly certain this general region is in this general region. I know how ridiculous it sounds. And so, Shatsky Rise, let's get an exact pinpoint on this, is this region. Possibly this as well. Let's see. So it's not flattened. Notably, it's not flattened. Like a Goyet. Like, this is flattened. This is just sheared at the top. This, not sheared at the top. How exactly do they have totally different shapes in the same general waters? I guess we come up with reasons, but it's kind of ridiculous to think these would form sharp boundaries. I guess if we like interpret it based on the materials, like, well, in this case, the materials were blah blah blah, and maybe that is something that's going on. I don't know. It would be interesting if it was. It wouldn't be like proof of plate tectonics. It's just like, oh, interesting. Let's see. So I guess it's maybe the totality of the region, inclusive of Tamu Massif. This Tamu Massif is a late arriver. I'm pretty sure it's 1,000,000 years old. No one's like precisely labeling it. Maybe this one. I guess it's just the whole region. It's just gotta be the whole region. It's a general ocean plateau. I was looking into these before. I didn't know what to make of it, really, especially not like nowadays. Not like nowadays. Surpassing Olympus Mons. Okay. So I believe this is where they are technically believing it to have been, is like right around, at least at a time, like he has motions where it slides in here.
And Collide of North America, somewhere in that window.
Mind you, this is before the rapid expansion of the Earth, so I find that interesting. It's beginning to interact with this like missing counterpart to this system here that formed at its boundary. I'm thinking it might even just be right there, and we don't realize it. Like it's across this boundary. Where there's because essentially there's a current coming from the mantle puncture hole going this way, across here, that then runs into this boundary right here. It's unclear if it did it before the slab moved. I think it did, and it was just holding like pressure on this, like they were just connected energetically as it moved, maybe. which would make sense for like even the bond that flooded through to connect Southeast Asia to Asia. But it looks kind of like there's a mirror right here. I was thinking it might be just mirrored across here for some reason. But maybe what he's saying is more reasonable. If it was mirrored across here, maybe it's just like the equal opposite, so it's like the Yellowstone hotspot. I mean, it's where like it's not just the Yellowstone hotspot, maybe.
And then, as long as it's still
Like it's coming in, bringing heat, interacting with the whole stretch of it.
attached to the Farallon plate, it would be dragged underneath North America, moving across this region. And that would be consistent with playing the thermal model backwards that he had done.
And this is essentially a higher,
Well, we'll see, no.
Okay.
So it's higher topographically.
okay,
So the question is, what's the effect in dynamics of having a higher crust?
right.
And it turns out that it creates more shear stress because it's a tighter.
I think he shows it moving through. I'm a little confused. Oh, it must be here.
Which you're moving the same material through. So
I
you
thought it
increase
was with the
velocity
same blob.
And the small hose versus the wide hose, the velocity goes up, so you actually get more substance. See, this works. So here's a little, using his cartoons for the western U.S., here's the conjugate Shatsky rise, 100 million years ago. So again, this is this topography, calculated topography. And the idea goes, this thing would get here somewhere around 90 million years ago.
So they're saying as it moves in, the dynamic topography drops in elevation with it. Almost like it's a downswell.
Here's the center of the rise. As it migrates to the northeast,
I don't know
as
what.
soon as there's a substance, now I'm just showing you the centers. Notice the maximum substance would occur in the front edge as it moves through.
So now, like around 72 million, we're really in that stretch where, like, I mean, assuredly, he must be saying this is. I haven't yet, like, seen him say this is causing the Rockies, but clearly he's connecting it to the Rockies, and I agree. Like, I agree, this is what happened. This Shatsky's thing, like, just seeing the data here is probably what brought the heat specifically. It's like a bubble that's separated from Shatsky rise that just swelled in the region. But that current. But that current, maybe he's just making it look so beautiful. Shit. It makes sense, but I'm not sure if it makes sense without plate tectonics. Like, it has to be, like, brought in. I'm not sure that is so. Like, I'd say it can't be sudden. Sorry, now I'm like backtracking because I feel like it collides with this current first of all, but more so, like, this doesn't move. How did this thing... So where is this? It would have had to been like right over here, maybe. Like maybe it was forming between the Philippines and like what would become British Columbia. Like forming in the, or sorry, Washington and Oregon and Vancouver Island. Maybe here, I can't remember how far up it goes. Maybe that island too. Generally here though. Like maybe it was forming like on a side of this, like here, and then on this side, like a heat swelled in. I don't know.
That's that blob you saw before. And it moves out of the picture.
So this is where I was a little bit like, wait a minute. She just moves it off. It just goes out of here.
So that's what I'm looking for. Is that feature? That may be the feature that generates things like the Western Interior Seaway. What's the relationship between that and the beginning of the Laramide orogeny? How does that relate to major unconformities? Can I pull apart whether I can see this evidence of subsidence followed by uplift behind it? The redder colors means that it's higher. So we're looking for all those sort of details. So if I make a cross-section, more or less, I guess not quite parallel to the direction of average motion here, I'm going to make a cross-section through this area from the southwest to northeast, based on his model results. And so he would suggest that basically here's the plate underneath, starting about 200 kilometers down here, moving beneath it. This is his reconstructed thickness using, again, the density anomalies that we see in the sites of Tanager.
Okay, this is my thoughts. This current comes through straight on, collides with this current straight on that's coming in from this way. Is that? No, I'm not sure. I was gonna say it like separated to 2 points. Is that like this current though? There's no connection to this, really. It's really connected here. How close is this to Japan? Not that close. That spine. Whoa.
This is his predicted topography from the effect of it. So there'll be a dimple.
Okay. Let's move on. I don't want to keep playing this. If you want to check it out, I'll put it in the description, hopefully. So, what else did I write down? Formed at triple junction 140 to 100 million years ago, according to Wikipedia. Oh yeah, okay. Let's keep playing this. Just maybe not. I thought it's too far. It's too far. It's too many minutes. So, Shatsky Rise, though. Let's really focus on this Shatsky Rise because it's in a position where I've been recently just being like, okay, pretty much the a plate formed, like solidly, relatively speaking, atop the currents that physically had a shape that was reflective of the currents. And then it slid away in the currents, though, like like solidifying lava can do in lava currents, but just in a big chunk kind of way. And so, and if Shatsky Rise, let's find a technical paper. I just Wikipedia, got it off Wikipedia. I just need anything to suggest a date. This really means it was formed before the plate moved, pretty much. While it was still, like, it was forming over here until what seems to be around 100 to 120 million years. So maybe even this thing has something to do with the plate motion. I don't know why it would. Maybe it's like a blowout valve happened here. Like the current was going in this way and then it was going in over here. So maybe it's physically like part of the batholith or whatever, the tube of just material that got formed that in an arc. I think he shows it set like this. By the way, like teeth again, like teeth, shallogram teeth, like. But it basically formed in a huge arc like this. That's still visible in part here. But like maybe like for sure this current managed to get through here, so maybe it took this material and just moved it instead of like making it go up this way. It just moved it out this way. I don't know if the materials of Shatsky Rise are in any way related to what's underneath of like Sierra Nevadas, because I'm pretty sure that's what this is. Although it does go pretty far up, so maybe. I mean, I'm pretty sure it is, though. Yeah. So the Sierra Nevadas got formed atop the material that Shatsky Rise is formed of, potentially. Let's see. The more I think about it, a blowout valve that got blown out and just scattered on the pre-existing oceanic crust that was forming like this. Like this blowout valve. Because this has been up here, really. So this is... Maybe if I redo this, it might be worth it. Let's do it. Let's do it real quick. Not like hard, not like extensively, just to see, physically to see what it looks like. if I, instead of coupling the boundary along the dragon like I was doing there, instead of that, I couple it along that, like, arc of the... You know what I'm saying? This arc. Okay. There. I don't want to change the scale. There. Photoshop. Real quick. Real quick. Take this, go like pretty much the boundary of like here. Trying to follow these segments. Okay. Cut it out, paste. So like this. Here's the pretty much where this current is flowing. This current coming in. That's pretty much what I'm trying to capture. To a degree. Okay, let's get that other one back. Put that on top. Probably turn it 45 degrees-ish. Oops. Fit on screen. Let's make this a little distinguishable. Okay. So what I'm trying to do is pretend like it's like lined up there. Is that what it was? It kind of looks like the shape. Down here. It also generally fits up to that boundary. I think there's some stuff going on up here that I'm not sure what to make of it. Let's see, but that would put Shatsky Rise here. Just really like way up here. What was I trying to figure out? Oh yeah, I was trying to figure out whether it'd be here. Oh yeah. What is there? It's real. I guess this thing. I don't know if I can do it better than I already did it. Like this side almost needs to be connected. Like there. I mean, it doesn't. It could be. I don't know. It could be. It could be. Just physically based on positions. It could be that it blew out a valve here, and maybe even blew out a valve here. Where initially it was just going through like a smaller segment here and flowing, but then it like blew shortcut paths out the sides. This one went down between down this way. Let's see, does that fit even like from that point? It's a lot of tabs. From like around here. I mean, this, it's not the worst. I don't know how precisely dimensioned I did this. I don't think it's very exact, so it's quite possible that's pretty close to where that, maybe it went out like that and out this way and this way and kind of turned 3 ways. I don't know. I'm feeling pretty good about that blowout valve idea. It seems like we would know that its materials were significantly different. Although I'm not even sure what that would be made of. The structure down below is probably just oceanic crust. Like this is probably, it's hard to say. Yeah, like after the boundary, I mean, it pretty much is one unit. I really feel like it's probably just oceanic crust at that point. In a way where, like, if it was here versus here, we wouldn't notice the difference. Or if it was here or out here under California or outside of, I don't know if we would notice the difference if it's in a mound. I mean, maybe it would have some oddities for sure, but it wouldn't be so pronounced where it's just like, why is there a granite like seamount of total different materials? I don't know if that was a good example for a material that would be odd, but basaltic plateau, which, I mean, that just generally makes sense for what that material would be. Although, again, it would be likely to have a lot of anomalies, and this is relating to magnetic lineations within. So it's coming out here and then up here, out here, and in here maybe even. Like this might actually be related to the current coming in. Because essentially this structure of the Mariana Trench, just like again, I don't know. I'm just thinking like, if this thing here maybe could be related. I have found this odd in the past. I didn't know what to make of it. It's just like scattering of seamounts, and then this. Like, what in the... It just looks like a bunch of dots in a diamond pattern. Like, what is that? It's to the east of the Hawaiian seamount chain. Here, not really visible. Although there's all these like really intense ridges and this current, so that they're meeting and then seemingly going through like a distance of vibrating out of sequence and then reconverging elsewhere and producing this structure. I don't know. It's very odd. Like the Shatsky seamount is part of this right here. This like, this is, to me, this is an out of sequence, out of vibrating out of sync of this current from the mantle puncture hole. Maybe the mantle puncture hole. Maybe that's what's happening. It's like the mantle puncture hole is feeding this. And then over time it like moves out of balance. Like initially they're in balance, but then over time the mantle puncture hole starts to like deflect upward in a way where it just like hits a wall and goes up, like the Rockies. Hits a wall, goes up, thrust faults over. Hits a wall, goes up, thrust faults over kind of thing. Which is really over here. So then it starts to go generally up this way and around. And in so doing, it like begins to flow around and back into this region, so that then over time it like has this counter currents, and not only is it approaching it from this angle, but it's then approaching from a second angle and just widening the current, I guess, until it can flow between, and then it just starts to open the current into two currents. Just talking, but it seems plausible. So what's going on here? Current from the mantle puncture hole, maybe also a current from this region over here. I think this goes generally to that region too. I'm not sure what to make of that one. That might go down here, down this way. It's hard to say without the data. This, oh my god. If this thing was filled in. Oh my god. But yeah, we see some stuff going on here that's really reflective of colliding currents in this location specifically. So I would say Shatsky rise did not form at a true triple junction. Maybe if there's triple currents here, but like it formed where it is and hasn't. I mean, it was maybe adjacent. I think this is it here. So it's like where current flowed. Because there was space for it to flow, it actually caused uprising. Formed during the late Jurassic and early Cretaceous, probably making it the oldest unaltered oceanic plateau. So I think that's around 250. Let's see. Yeah, that's pretty much what they're saying here. Igneous construct. Oceanic plateaus are major ocean features, yet their origin and development are poorly understood. Many are huge piles of basalt, and it is widely huge piles of basalt. And it's like they were huge piles of basalt. And it is widely accepted that mantle plumes are their source. Perhaps from eruptions of the voluminous head of an emerging plume. Shatsky rise. So maybe mantle plumes are their source. Maybe there is, like, when I don't know exactly the process of how the currents are flowing. Like, I've been interpreting it that the mantle was punctured and upwelled. But maybe the mantle was punctured and the current flowing within the mantle was just like producing it to emit heat in ways that then caused flows. But I mean, it certainly released basalt oceans, and basalt was moved, and this was all moved and shaped. So, like, I'm not sure what to make of it. But maybe there's something like underneath the crust completely happening. That's not like that's within the mantle. That's more subtle ways than I'm describing it as. Unlike many mid-Cretaceous plateaus, is a basaltic plateau that formed during a period of geomagnetic reversals. Mind you, magnetic reversals are tied to the Earth expansion process. I'm not sure what to make of them. Like, it's not that the poles are just shifting. Doop, 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 doop. That's not what's happening. It's that the Earth's expansion is like above and below equilibriums in some way. So maybe it's like releasing energy, release, and then it like boom, explodes because it has too much pressure into the system, and that like or release from within release from within, which then builds up in the exterior until some kind of like boom outgassing event that then like allows for like a gasket to blow like over here, where the pressure's coming down this way, but the mantle is flowing out this way. So there's this like basin region that forms that then outgasses practically to cause the vibration of this arm to produce the Himalayas arcs. Like the shapes of the Himalayas are tied to the vibration of this. So I'm not sure what to make of geomagnetic reversals, and I just have avoided it in a general, like, I don't know what to make of it. We'll see when I get there kind of way, and not been too worried about it. It's not like avoided, just like, eh. I know it's not what it's said to be. Okay, that's a good start. Unlike many mid-Cretaceous plateaus, during a period of geomagnetic reversals, unlike many mid-Cretaceous plateaus, so magnetic data can help us understand its tectonic history. That to me suggests like it might have been the blowout valve that like occurred at a time of a reversal when the energy release allowed for like the balance to change so that the pressure builds up again, and like the pole shift, maybe it is like totally a pole shift in essence. That's just like it's flipping, like it emits energy outward, and then it like some particle decays, then shapes the region enough to allow for something. But in this case, maybe it was the like thing that was decaying to cause to basically be like the breaking, the wall broken that allowed for like massive buildup to outgas through this current. Like once this wall broke and it broke the bonds of the continent, then it just free flowed out into the region, and so like pressure could be stabilized. So it needs to have like actual like broken bond gasket things of this nature, like. So there's Shatsky Rise, maybe. Let's see if that makes any sense as I keep going. Let's see, it's an hour 13, it's 2:30. I might have to just stop just because of time. Just like always, I'm just like constantly looking at new things and considering and not like getting completely through anything. Maybe let's scroll through and just see if there's any really exciting images. 250, 240, 230, 220. So we see it's kind of like the first current goes off this way and goes around. Like it must start swirling around like this with like new added layers here. It might even go all the way like that initially. I don't know. Or yeah, it's probably just going just barely open and just producing larger novas. But maybe though, as it's doing it, it's actually producing layers outward like this way. don't know if that's related to the ocean floor or if it's related to Shatsky Rise. These dates, like the segments. It's a Slitter Basin. Let's do black and white. Okay. I don't know what I was hoping to find by searching again. I'm just too tired to look at the words that closely. But I need to, so I guess I'll just leave. I'll see y'all in the next one. Peace out. Thanks for hanging out. See you. Happy thingamajig. That's not yet here yet, so.